All right. So picking up from our last class, where I introduced you to the concept of consumer surplus. Consumer surplus is a fairly important concept within the context of supply and demand because it becomes one of the ways in which we analyze changes to market scenarios. So when a market sees a supply or a demand shift, or the government imposes a tax or a subsidy, if there's any sort of change to a market for any particular reason, um, there are ways in which economists are interested in measuring the effect of those particular changes. And so consumer surplus forms sort of like one half of how we contemplate, analyzing those changes, and the other half, of course, being producer surplus. And the producer surplus sort of story um, is like most sort of producer surplus story, or producer problem stories rather, even more straightforward than the consumer side, because for producers, and we're still sort of moving in that particular direction. We'll actually probably start some producer theory um, in the next couple of classes. The producers are maximizing profits, minimizing costs, and so it's a little bit more straightforward, very non-abstract. Whereas on the consumer side, we're still dealing with this sort of utility concept, and so it tends to be a little bit more abstract. And so as a result, a little bit more care should be taken when we describe these particular concepts. So anyway, going back to where we left off from last time, we're going to consider this basic utility function here. We would describe this as a quasi-linear utility function. We didn't talk a lot about quasi-linear utility functions early in the semester, but suffice it to say that they're just one of those, simple and straightforward ways that economists sort of think about utility functions that make things a little bit more easy for us to understand. And so the idea, the basic sort of structure of the quasi linear utility function in this context is that utility here is coming from two goods. X is a discrete good. Discrete means that we can only consume whole numbers or integer amounts. So we can do 1 unit, 2 units, 3 units. We can't do 1.5 units, 2.5 units, so on and so forth. So when we say a discrete good, we just mean that you could only consume integer amounts of that particular good. And then Y is going to be what we call the numeraire, which we talked about earlier in the semester. And that's just going to be everything else other than X. So all the other goods that we consume other than X is going to show up in Y. And then the cool thing about this is that if you set the price of Y, as we do, to be 1, then actually Y just becomes your consumption of all the other goods that you consume, the amount of money you spend on those particular goods. And so that has a nice little simplicity to it that we'll see in just a moment. And then the V of X here. So what is V of X? V of X is what we sometimes refer to as the indirect utility, which is just simply our way of taking the concept of utility and sort of converting it into a monetary value, so an actual dollar value. So when you see a V of X there, basically what V of X would describe is the monetary value that I have for a certain level of consumption for X. And so V1 would be the value added from consuming 1 unit of X. And we're going to translate that into a dollar amount. So that's the trick here is that this V of X here ends up representing a dollar value that someone has for the good in question. Here, that good is X. And so in this sense, you can see that both sides of the utility function, V of X and Y, just represent money. V of X represents the dollar value of the good to the consumer, based on the way in which the utility function translates value. So the difference between V of X and Y is that Y is just the amount of money that I spend on all goods other than X, right? It's just, whatever else I'm consuming other than X, how much money I'm spending on X. And that's going to represent my utility from those goods. So you can think about it like every unit of good other than X gives me $1 of value, right? Because we've set the price of Y to be $1. And we're saying that the utility that I get from Y is just equal to Y. So in that sense, it's a little straightforward to think about Y, every unit of Y generating $1 in value. And so therefore the utility for Y is equal to 1. So if like, for example, if I consume no X, I'm not getting any value from X, but I consume 1 unit of Y, then my utility is going to be 1, right? Because my utility would be equal to V of X, which is 0 in that circumstance, and then the 1 unit of Y. So in that sense, what we've done with the utility function here is we've essentially translated into a utility function that reflects dollar values. Now, for X, what we're allowing X to do is there to be a little bit of a deeper utility meaning to X. In other words, that it's not simply that every unit of X gives us $1 in value in the same way that a good Y does. In fact, we're V is a function of X in this scenario, and V, is going to change. So it's not a constant function. It's going to be a function that changes. So to that particular point, what we did on in last class is I introduced you to the concept of a reservation price, and that's what these are. These are three different reservation prices for the good. And the basic idea behind a reservation price is that your reservation price for a particular amount of a good is going to be based upon your change in value for that good. So in this particular case, the reservation price for X is simply going to be the change in value that I experience when I increase my consumption of X. So when I go from 0 units of X to 1 unit of X, that generates a reservation price R1. Then when I go from 1 unit of X to 2 units of X, that generates a reservation price of 2, and so on and so forth. And then we can sort of think about it in a sort of more aggregate sense, where the value that I get, the difference in value from say 0 units to 3 units of X, I'm looking over here, um, would simply be all those reservation prices added up. So the reservation prices constitute changes in the value that we receive when we change our consumption of the particular good. Now, like I mentioned in last class, this means that reservation prices are tied to marginal utility. Now, in this particular circumstance, the change in utility that I get from X is literally the change in value. If I were to take this utility function, let me get rid of this stuff here. If I were to take this utility function and I would ask myself, what is the marginal utility of X in the context of this particular utility function, then the marginal utility of X would simply be equal to the marginal value of X. What I mean by that is the marginal utility of X is going to be equal to, I'm going to do V prime X, where V prime X refers to the change in the value of X as I change my consumption of X. Those of you who have a calculus background, V of X, V prime of X here just means the derivative of the value function with respect to X. Just like marginal utility is the derivative of the utility function with respect to X, the marginal value of X is just the derivative of the value function with respect to X. But those of you that don't have a calculus background, it's not that important here because all we're saying is that the margin utility of X, that is the incremental change in our utility when we consume X, is simply going to be equal to the marginal value of X as we increase our consumption of X. And so the way that you can think about that here is that we have the change in the value of X divided by the change in the quantity of X. So the change in the amount of units of the good that I consume related to the amount that my value changes is going to be equal to marginal utility. And so what that means is that these reservation prices are simply equal to the marginal utility of this particular utility function, because you'll notice that R1 is just the difference between the value I get from consuming 1 unit versus the value I got from consuming 0 units. So it's just this change in value divided by the change in the quantity of X. And the change in the quantity of X is almost always just going to be 1. And so here, again, to sort of drive home that point, the reservation prices that consumers have for a particular good is going to be equal to the change in value that consumer feels when they increase their consumption of the particular good. Now, since the price of Y, as we've already stated, is just 1, this means we can actually rewrite the utility function in a very simple way, which we do right here. So the way that you think about this utility function is that, of course, we have the value of X that stays the same. Then the amount of money that I can spend on non-X goods is going to be simply equal to my income, M, minus the amount of money I spend on N units of the good. So in this particular case, I consume up to N units of the good. Here, that's good X. And then I just simply take that amount of money, which would be multiplied by the price of X, and I subtract that off of my income. So it might be better, I guess, if we could sort of do this, if we put a parenthesis here and here, where this is just my income minus the amount of money I spend on good X, and then plus the value that I get from X. That's going to be the consumer's utility function. So it's just a nice way for us to kind of reframe the utility function and put it into more basic terms. You know, all semester we've been sort of talking about the abstractness of utility functions, but in this particular case, because one, we've assumed we have a quasi-linear utility function, and because secondly, we assume that Y is a numerator good and set that equal to the price of 1, it allows us to have a utility function which is a lot more realistic. It feels a lot real, you know, if you think about it sort of that way. So imagine like X is some like fun good, like maybe X is, uh, you know, um, the number of movies you see in a given month, and then Y is just everything that you don't spend on movies. And so the change in happiness, the change in utility that you receive from seeing movies is going to be a function of the number of movies that you see. Whereas the utility that you get from consuming all the other stuff in your life, groceries, rent, and everything like that, we're going to assume is just equal to however many units of those things you happen to consume, which I think makes quite a bit of sense. The other thing that we talked about in class on last class was that the reservation prices decline as we consume more and more of the good. So if we graph the reservation prices in PQ space, so notice this is PQ space, which is of course the same space that we plop our demand curves into. If we just draw vertical bars representing the level of reservation prices at particular levels of consumption, so consuming 1 unit of X gives us a reservation price of R1, a second unit R2, third unit R3, so on and so forth. We see that the reservation prices decline. And the reason why we typically say this is because of diminishing returns. In other words, the change in the value of X relative to the consumption of X is going to decline. So if we, for example, go back to this here, what we're saying um, is that this right here decreases as we consume more and more X, which would imply the marginal utility for X is declining. That sounds like diminishing marginal returns to me. And so the full story here is that the reservation price reflects the value of consuming one additional unit of the good. And the change in value to consuming one additional unit of the good has always been marginal utility. Here, we've just taken the utility function and we've made it much more straightforward so that we can put everything in terms of dollar amounts. And the reason why we're doing that is because ultimately we want to translate utility into a quantifiable value that we can use to measure the concept of consumer surplus. So let's check in on that. So the basic idea of consumer surplus can be illustrated in this particular graph. So we have the bars representing the reservation prices. So R1, R2, R3, and R4. And then we have a price. So here's the price of X. So this is a market price. So this is a price, being set by a market, and we can see that that market price falls between 2 and 3 of units of X. And so what that would imply in this particular circumstance is that ultimately 2 units of the good are going to be consumed because the reservation price for 2 units is greater than the price of X, but the reservation price for 3 units is below the price of X, right? And you'll recall one of the things that we talked about um, on last class is that we have this sort of general structure, which is that the reservation price is going to be between um, the price, rather, the market price is always going to be between 2 reservation prices. All right, there's always going to be so wherever the market price is, it's going to fall between um, 2 different reservation prices. So the reservation price of the one less unit, in this case R2, and the reservation price for 3 units, or n plus one, which in this case is 3. And so ultimately, the idea here is that because this consumer has reservation prices of this particular structure, then the consumer will end up consuming 2 units because it's not worthwhile for them to consume the third unit. The value they get from consuming that third unit is not at least as much as the price. So rationality dictates that they don't consume 3 units, they only consume 2 units. And so that's the basic idea of reservation prices and consumption decisions. So my demand for a good is based upon my willingness to pay for the good. Well, reservation price is just willingness to pay. And so what we're saying is that someone's willingness to pay for a certain amount of the good, and then one more unit of those goods is also going to have a distinct willingness to pay. And so if a market price falls between them, you're going to consume the amount of the good where your reservation price is still at least as high as the price. Now, as far as consumer surplus goes, what this would imply is that the consumer ends up getting consumer surplus equal to the amount of the summation of their reservation prices minus the price. Right? You'll see that here the area of this first vertical um, uh, bar right here. That's the reservation price for 1 unit of the good. And then the second one is the reservation price for the second unit of the good. And so normally, of course, the value, the sort of gross value would extend all the way down to the horizontal axis. But of course, the price of X here we can see falls between the two. and therefore the net surplus that this consumer gets from consuming 2 units of the good is going to be represented by the areas that I've shaded in here. So those 2 areas are going to represent the consumer surplus. So, what does consumer surplus ultimately mean in sort of plain language? Consumer surplus is the surplus value that a consumer gets when they consume a good at a price below reservation prices. So you can see that this consumer has a high reservation price for 1 unit, a relatively high reservation price for 2 units, and then the market price falls between the reservation price for 2 and 3 units, and so therefore the surplus that the consumer gets is going to be equal to the value they get for the consumption of however many units they consume. So in this particular case, we could sort of rewrite this as, oops, we could rewrite this as consumer surplus is equal to, and we can say Q here is equal to 3. And so V of 3 minus PX times 3. See, that would be the oh no, excuse me. Oops. Back her up, back her up. 2. I don't know why I said 2. So let's go back. That'll be okay because it'll allow me to rewrite this in a little bit neater way. So consumer surplus when Q is equal to 2 is going to be equal to the value of 2 units of consumption minus whatever we're paying for the price of X times 2 units of consumption. So you can see the first part of this is the value the consumer gets in dollar terms from consuming 2 units. And then the second part is what they spent in terms of value to consume the 2 units of the good. So every time you consume a certain amount of a good, if you are lucky enough to pay below your reservation price, then you get surplus value for that particular good. And now the truth is that some people will this will not be true for all people in a given market, because reservation prices are based off of um, utility functions. And so some people's reservation prices will be very low, and some people's reservation prices for certain goods will be very high. And ultimately, this is, of course, where we get the demand curve from. So if we go to this graph here, these 2 graphs. So I've drawn a really sort of crude situation over here to the left. So we're looking over here, and what's going on here is what we've taken the idea of reservation prices and we've aggregated them up to all the consumers in a given market. And then what we basically say is that at each reservation price, that represents a point on a smooth indifference curve. So I just go down here and I put all these dots. You'll notice that these dots correspond to the reservation prices at all these given particular levels. You'll notice that for the entire market, we get that same downward sloping situation as before. So our assumption of diminishing value as we consume more units extends to the market as well, which I think is a very interesting sort of concept. Like we ourselves get diminishing returns when we consume more and more units of a good. So does the market. The market also receives diminishing returns because the returns that consumers get when they consume goods from a market are based upon the reservation prices, right? Your willingness to pay determines the value that you receive when you consume a good. And as more and more and more and more and more people buy a good at a given price, then that means the reservation prices are also declining. So, for example, let's say that we sort of contemplate some price here, and then we contemplate a second price here. We'll call that P prime. So if the price of the good declines, so at P let's say that's 1, 2, 3, 4, 5. And then at this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As the market moves from consuming 5 units to consuming 11 units, and the reason why we know that the market's going to do this is because the points on the demand curve represent willingness to pay. They represent reservation prices. So you can basically think about taking the concept of a reservation price at the individual level, and then what's going on here is imagine that there's like groups of people out there. Okay, there's groups of individuals out there, and there are people who have very high reservation prices for the goods, and there are people who have very low reservation prices for the goods. And depending upon the price, that's going to determine who buys the good and who doesn't buy the good, right? So, for example, you can see at a price P1, right, which corresponds to this reservation price here, you can notice that all of these people here do not buy. Why don't they buy? Because their reservation prices are below the price as it currently stands. Then, of course, what happens is that the market price falls to P star. Now the reservation price is here, and there are still people who don't buy the good, in this direction of the demand curve, but it's far fewer people because the market price has fallen. That means a lot more people's reservation prices are equal to or greater than the market price, and so a lot more people buy the good. And so the basic mechanism that we've talked about all semester about consumers buy goods when their marginal utilities tell them to, right? That's been sort of the story. I mean, not have actually sort of framed it in that way. The semester said it that particular way, but we know that marginal utility is ultimately what ends up kind of defining consumption decisions. And so in the case of consumer surplus, all we're saying here is that the market gets value from the fact that there are individuals who have potentially high reservation prices, but they end up paying relatively lower prices as a result. So, for example, if we were to look at this, if we just sort of ignored um, the second price here, let's just get rid of that, and we'll just look at this from the perspective of P, which resulted in 5 units of the good being consumed. Then we just add up like we did over here, right? Back in this graph. All we do is we just add up the area, the shaded areas, which is the areas above price and below reservation prices. And so if we did that, then we would get consumer surplus at a price of 5 would be equal to the area corresponding to the summation of these particular levels. Now, these are, of course, I'm going to kind of draw it here. These are points, and then we're drawing a demand curve along them. Oops. Right. That's what's going on here. So there's all these reservation prices, and you sort of put the points on the corners of them, and then we just draw the demand curve through them. So when we see a smooth demand curve, like the way that we typically see demand curves as being very smooth, wow, that is just such an ugly picture. Hold on, I have to redraw that. It was so bad. Um, all right, so all the points represent reservation prices, and then we just draw our demand curve through the points. So when we see the smooth demand curve, like what we see over here, all we're doing is we're approximating the idea of reservation prices. And instead of showing all of those kind of awkward, bars with 90-degree lines, we just draw smooth demand curves. And so, in some sense, we're this is a sort of an imperfect process, right? Because there's these little sort of triangles between that we're just kind of adding up. But it makes our life a lot easier to deal with smooth demand curves as opposed to stepwise demand curves. We could, by the way, if we wanted to, we could leave our demand curves like this. That is actually, in fact, in some sense, a more realistic version of a demand curve. That's kind of typically the way it looks. Like if you were to ask a class, what is your willingness to pay for a particular product, which I did with you all last class, you would see steps typically, in the demand curve. But the problem with that is that that creates all sorts of problems when you start adding in the supply function. So it's much better for us to have a smooth demand curve. And then just sort of to wrap up the conversation of consumer surplus, to go back to what I was originally saying, the reason why the reason why economists contemplate consumer surplus is ultimately because we're interested in what happens when things change. So here you can see two different prices, PX and PX prime, that correspond to two different quantities being purchased in the market. And it's important here to understand this is a market. We're not describing individual behavior. We're describing now all the consumer behavior in the market. So again, we've gone from individual utility functions, and now we're aggregating up to market demand. And so what's happened here is that the price of the good rises from PX to PX prime. The amount of the good being consumed falls from QX to QX prime. But in addition to that, there's a loss of consumer surplus. In particular, the original consumer surplus, which I will highlight now with green. So the original at the original price, consumer surplus would have been roughly that triangle there. That would have been what consumer surplus was at PX. So at PX, the green triangle represents roughly what consumer surplus would have been at that particular price, and so not just at that particular price, but at that particular level of the product being consumed. What that triangle represents is that surplus value, that R n minus P for all the different consumers. I should say Rn minus P n for all the different consumers in a given market. And then after the price change occurs, we'll show this in blue. Now consumer surplus is only that blue triangle, so it's less, and so the difference or the loss in consumer surplus is this sort of trapezoid looking figure right there. So this area here is the loss in consumer surplus. And so what we can say is that when the price of a good rises, consumers are made worse off. The total value of consumer surplus can be thought of as basically how well off are consumers in a given market. And if consumers lose consumer surplus, that means they're made to be worse off. And so generally what we can say is that as the price of a good falls, consumer surplus for that good is going to increase. And as the price for a good rises, consumer surplus is going to decline. Now, like I said, why are economists sort of interested in this? Well, for example, let's say we wanted to isolate the effect of a tax, a commodity tax placed in a market. Oops. So we can do that very easily here, which I'll show you. Let's move this up here. So the way that we would show that would be like this. So classic supply and demand. I'm just going to do linear demand for simplicity here. And then supply. We haven't really gotten to supply yet in class, but you should have remembered that from your principles of econ. So we have some market price, we'll call that P star. We have some market quantity, we'll call that Q star. And then the government comes in and they impose a tax. And so let's do that with, let's do red. People don't like taxes, so we'll illustrate with red. So the government taxes, um, and so it creates a price paid by consumers and a price received by producers. And the distance between these two is the tax itself. And so now what occurs is there's an after tax quantity QT like that. And you can see that because the price that consumers now pay for the product, their consumer surplus is going to decline. Prior to the tax, consumer surplus was the green triangle. Consumer surplus was that entire green triangle. And then after the imposition of the tax, the consumer surplus now is only that red triangle. So the after tax consumer surplus is considerably worse than the pre tax consumer surplus. And then I'll just show you that loss in consumer surplus. So this green area here, this is the loss in CS from the tax. So that area there and that area there. So when the government imposes a tax, not too surprisingly, consumers lose because their consumer surplus is declined. And so one of the more important things that policymakers have to contemplate is how much am I making consumers worse off relative to the point of the tax, right? Taxes are like any policy, they have a particular point for existing. And so, how much consumers are made worse off from a particular tax is a really important question that policymakers would be interested in. And again, highlights the reason why consumer surplus ends up being such an important sort of concept here. Now, one last thing I just thought of that might be kind of worthwhile to contemplate um, is what affects the size of consumer surplus. Um, so, in other words, what I mean by that is, are there things that affect the size of consumer surplus? The answer is yes. Um, they're the same things that affect the shape of the demand curve. So, for example, let's say we have very steep demand here for a good, and then we have very non-steep demand for a good here. And then let's just change price. So we'll keep the change in price roughly the same. Try to at least. Okay. So initially, producer surplus was in these scenarios roughly that triangle, and here roughly that triangle. That was original consumer surplus prior to the price change, and then after the price change, we now have consumer surplus that triangle and that triangle. So you can see that the shape of the demand curve affects the change in consumer surplus. Because if you look at the increases in consumer surplus here, which I'm going to shade here, so the shaded region reflects the increase in consumer surplus at P prime. So that and that. And then over here, that's the same thing. But what you'll notice is that this is much bigger than this. So, in other words, the steeper the demand curve is for a particular product, the less benefit consumers have from decreases in price. Whereas the less steep the demand curve is, the more benefit consumers will tend to feel from decreases in price. Now, it's sort of interesting because what makes a demand curve very steep? Well, a steep demand curve would imply this is a good with no close substitutes, meaning that you generally have to buy it. And then a demand curve that's very unsteep would be a good that has a lot of substitutes. Um, and so it can be a little counterintuitive. You would think that price decreases for things we had to buy would lead to greater changes in consumer surplus. But you have to remember the things we have to buy them sort of regardless of the price. And so price changes don't materially affect us very much. We just end up buying essentially the same amount. Whereas for goods that we don't have to buy, reductions in price can lead to substantially large increases in the amount that's actually consumed. Right? Notice this increase in the quantity is much greater when the demand curve is flat than when the demand curve is steep. What that would imply is that when the prices fall in the unsteep market, then you get a lot more consumers willing to buy the good than you do when the demand is very steep, which should make a lot of sense. So basically, the idea is that at price there were a lot more people unwilling to buy the good in the flat demand curve, and then when the price changed, a lot more people were willing to buy the good now at P prime than they were willing to buy at P. So again, just some more applications of consumer surplus. It's one of those very kind of basic ideas that um, you know, on the surface, it sort of seems kind of boring. And what can you do with this? But then when you actually start applying it to all these sorts of different scenarios, you see that it's actually kind of opens up a whole world.